We are almost halfway now at video 9, Asynchronous Programming with Callbacks. In modern web development, asynchronous programming is essential for providing a smooth and responsive user experience. Unlike synchronous programming, where operations happen one after the other, asynchronous programming allows tasks to operate independently of the main program flow. Callback functions are one of the ways to handle this asynchronous behavior. Let's dive into this topic. Section 1. Understanding asynchronous programming. Imagine reading a complex book with footnotes. You can either pause your reading to check every footnote, which is synchronous, or jot them down to check later, which is asynchronous. Asynchronous programming lets your code continue running while waiting for a long task, such as a file read or API call, preventing any freezing of the application. Callback functions in asynchronous programming. Introduction to callbacks. A callback function is a function passed into another function as an argument, which is then invoked inside the outer function. It's like setting an alarm to remind you of something later. Simple asynchronous callback example. JavaScript setTimeout method is a simple example of asynchronous behavior. It sets a timer and executes a callback function once the timer expires. In this code, notifyMe takes a callback function and executes it after 3 seconds. When the timer expires, the message 3 seconds have passed is logged to the console. This example demonstrates how you can use a callback to schedule a piece of code to run later, allowing the rest of your code to run unblocked in the meantime. Asynchronous callbacks with file reading, Node.js example. Reading a file from the disk is a common asynchronous operation. In Node.js, you can use callbacks to handle this. In this part, we've delved into the core of asynchronous programming and explored how callback functions allow us to handle tasks that take some time to complete. Whether it's waiting for a timer or reading a file, callbacks give us the ability to write non-blocking, efficient code that can handle the multitasking demands of modern web applications. Next, we'll further explore handling complex asynchronous code with callbacks, opening the door to more advanced patterns and practices. Earlier, we saw how callbacks enable us to write non-blocking code by scheduling tasks to run later. Now, we'll dive deeper into handling complex asynchronous code with callbacks, discovering patterns to manage multiple async operations and avoid the infamous callback hell. Handling multiple asynchronous operations. Chaining callbacks. When you need to perform multiple asynchronous operations in sequence, you can chain callbacks. It's like a series of dominoes, each one triggers the next. Here, first task takes a callback, which is second task, and calls it after a 2-second delay. Once the first task is done, the second task is executed. Chaining callbacks allows you to maintain a specific order of execution for asynchronous tasks. Nested callbacks. Sometimes you may find yourself nesting callbacks within callbacks, known as callback hell. This can lead to complex and hard-to-maintain code. This code fetches data in 3 steps, each depending on the result of the previous step. While it achieves the goal, it can be challenging to read and maintain. Nested callbacks can solve complex asynchronous problems but may lead to unreadable code. Recognizing this pattern is essential, as there are modern alternatives to avoid this problem, such as promises and async/await. Error handling in asynchronous code. Handling errors in asynchronous code can be tricky. Since the code doesn't run sequentially, traditional try-catch blocks may not catch errors within callbacks. Error-first callbacks. A common pattern is to use error-first callbacks, where the first parameter of the callback is reserved for an error object. In this example, the callback takes 2 parameters, an error and a result. If an error occurs, it's passed to the callback, allowing the calling code to handle it. Error-first callbacks provide a consistent way to handle errors in asynchronous code, making your code more robust and maintainable. Asynchronous programming with callbacks is a powerful technique that enables smooth and responsive user interactions. We've explored how to chain callbacks, handle errors, and manage complexity. While callbacks are foundational, the JavaScript ecosystem has evolved, offering even more elegant solutions to handle asynchronous code, such as promises and async/await, which we'll explore in upcoming videos. By understanding the core concepts and patterns behind callbacks, you've taken a significant step towards mastering asynchronous programming. It's a skill that will serve you well as you continue to build more complex and interactive web applications. Thank you for joining us on this journey, and stay tuned for more in-depth explorations of modern JavaScript techniques.